Online lecture series we are going to start, and we will study applied thermodynamics. So we are going to start here Unit 4. What topics we have to learn in Unit 4? That is objectives of testing and performance parameters of IC engines. These two topics basically we have to learn today. If you see syllabus, if you see Unit 4 syllabus, what topics are included in Unit 4? See objectives of testing, then various performance parameters that you have to learn in this particular unit. What parameters we have to learn? Indicated power, brake power, friction power. We are already familiar with. We have done experimentation. Okay, and we have learned these concepts in that particular experiment. Also, we have to see various performance parameters, various performance characteristics. Also, we have to study. So, what are the objectives of engine testing? Let's see. Understanding performance parameters in evaluation of IC engine performance. So what are the performance parameters? Various performance parameters like brake power is there, like BSFC is there, ISFC is there, brake mean effective pressure are there. So all these parameters we have to study. This parameter affects our engine performance. This parameter affects our engine working. Okay, so that's why we have to study this engine performance. So next objective that we should know, that is calculate the speed of IC engine. Why we have to calculate the speed? We know we have to calculate power. To calculate power we require speed. When we calculate speed, then we will know it is low speed engine or high speed engine. When we will calculate speed, we can compare various performance parameters with this speed and we can plot our characteristic curves. Also we have to learn what is fuel consumption. We know when fuel will get consumed, it requires some cost, right? Fuel requires some cost. As fuel will get consumed, more and more fuel will get consumed, that engine will not be economical. Okay? So we have to calculate fuel consumption. So we can calculate how much will be the BSFC. What is BSFC? That is brake specific fuel consumption. How much fuel has consumed to get 1 kilowatt in 1 hour? That is BSFC. So we require this fuel consumption value. So we have to work on this parameter also. Air consumption, we have to calculate volumetric efficiency. To calculate volumetric efficiency, this air consumption factor is very important. What is other objective? Evaluate the exhaust smoke and exhaust emission. This is very important parameter. Nowadays you have seen BS6 has introduced in India. But they are saying we have to lower down the emission level. So it is important to study this exhaust smoke and exhaust emission parameters. Differentiate between the performance of SI engine and CI engine. So what is performance of SI engine that we have to study? How we can evaluate performance of SI engine? What are the parameters that we have to study? And comparative study also we have to do in this particular objective. So these are the basic objectives that we have to learn in this particular unit. So let's start with power. So this is one basic parameter by which we can analyze engine performance. Now you are familiar with this word horsepower. But from where this word comes, horsepower? This word or this concept is coined by James Watt. In 18th century, he have coined this concept, horsepower. This is one of the parameters which affects the engine performance. This concept is coined by James Watt. काय केलं जेम्स वॉटनी? हॉर्स पॉवर, हॉर्स कुठून आला याच्यामध्ये? आपण जनरली म्हणतो पॉवर किलोवॅट मध्ये. आता हे हॉर्स पॉवर आपण बघतो की बरेच इन्स्ट्रुमेंट आहेत, जसं की चेन सॉज आहे, नंतर व्हॅक्यूम क्लीनर्स आहे, किंवा तुमची मोटर घ्या. तुम्ही आज घरी गेल्यावरती मिक्सरमध्ये बघा, त्या मिक्सरवरती काय लिहिलंय की HP असं लिहिलंय, म्हणजे 0.5 HP 1 HP असं लिहिलं असणार. तर व्हॉट इज दॅट HP? दॅट इज नथिंग बट हॉर्स पॉवर. तर आता हे हॉर्स हे आलं कुठून? तर बघा जेम्स वॉटनी काय केलं, त्यांनी स्टीम इंजिन्स तयार केली. स्टीम इंजिन्स तयार केली तर त्याला माहिती घरात ठेवायचे होते का? नाही, तर ते विकायचे होते किंवा त्याला ते दापायचे होते लोकांना. ती आयडिया ती प्रपोज करायची होती. तर त्यांनी लोकांशी बोलायला चालू केली. आता लोकांचं जे आहे ते कन्व्हेन्शनल जे बग्गी असतात आपल्या, ज्याला घोडा लावलेला असतो, तर ते वापरायचे. आणि त्यांना लोकांना कसं बदल नको असतो लगेच, किंवा ते रजिस्ट करतात, नवीन बदलाला ते रजिस्ट करतात. आता हे स्टीम इंजिन्स आले ते कसे चालणार, ते व्यवस्थित वर्किंग करणार का, त्याला चालवणार जर आपण नाही ऑटोमॅटिक कसे चालणार, असे लोक प्रश्न विचारणार तेव्हा. आता हे आपल्याला सोपं वाटतं की गाडीला किक मारली आणि आपण लगेच घरी गेलो किंवा पुढे फिरायला गेलो, पण आता आपल्याला काय एवढं वाटत नाही. पण तेव्हा जेव्हा नवीन स्टीम इंजिन झाले तर त्याला किती विरोध झाला असेल तुम्ही विचार घ्या. तर त्याला तरी एक्सप्लेन करावं लागलं असणार त्याला. मग त्याला लोकांनी कदाचित विचारलं असणार की हे इंजिन आहे ते कसं पॉवर प्रोड्यूस करतंय, किती पॉवर प्रोड्यूस करतंय. मग आता जे कन्व्हेन्शनली ते जे वापरत होते की घोडा वापरत होते ते पुल करायला ती बघी, तर तो जो घोडा होता तो त्याला मिनी पोनी असं म्हणायचे. मिनी पोनी म्हणजे काय, तर एक घोडाच आहे, फक्त घोड्यापेक्षा थोडा छोटा, आपण जे खेचर म्हणतो आपल्या मराठीमध्ये, तर तशा प्रकारचा तो घोडा आहे. आता तो घोड्यापेक्षा कमीच पॉवर प्रोड्यूस करणार आहे, तर तो किती पॉवर प्रोड्यूस करतो, तर जेम्स वॅटनी थोडीशी ऑब्झर्वेशननी काढलं की तो 22,000 फूट पाऊंड. आता हा स्कॉटिश सायंटिस्ट आहे किंवा स्कॉटिश इंजिनियर आहे, तर त्यांनी फूट पाऊंडमध्ये तेव्हा ते सगळे कॅल्क्युलेशन केलेले. आपण केले असते तर ते कशामध्ये केले असते, तर आपण इथं आपण असं मीटर आणि इथं आपण असं आपण न्यूटन, तर न्यूटन मीटर म्हणजे काय जूल, तर आपण जूलमध्ये आपण ते वर्कडन काढलं असतं. तर तो काय म्हणतोय की 22,000 फूट पाऊंड एवढं वर्कडन तो घोडा करतो. आता हे त्यांनी कसं काढलं असणार आहे बघा, तर 220 पाऊंड आपण घेतो आणि 100 फूट आपण घेतलं, तर हा घोडा एका मिनिटाला किती लांब जातोय, तर 100 फूट जातोय. समजा एका मुलाला त्या घोड्यावरती बसवलंय तर तो 100 फूट घेऊन जाणार आणि त्या मुलाचं वजन किती, सो 22,000 फूट पाऊंड. That much work will be done by mini pony. So horse is bigger in size, or how much work he will done? He will done 33,000 फूट पाऊंड एवढं वर्क त्यांनी केलं. आता तुम्ही 33,000ला जर फूट पाऊंडला जर तुम्ही वॅटमध्ये कन्वर्ट केलं, त्याला वॅटमध्ये कन्वर्ट करायला लागणार तुम्हाला, तर तुम्हाला मिळणार ते 746 तुम्हाला एवढं मिळणार. तुम्ही इंटरनेटवरती जाऊन त्याला कन्वर्ट करून बघा, तर तुम्हाला अराउंड 746 मिळणार. सो व्हॉट इज 1 HP, तिथून काय मिळालं आपल्याला 1 HP ची व्हॅल्यू मिळाली. व्हॉट इज हाऊ मच 1 HP? 1 HP इज इक्वल टू 746 वॅट. So 1 horsepower is equivalent to 746 watt. And nowadays for generator we are using same unit, HP. British unit also you should know. So conversion of British unit is also given in this particular slide. I will share this PPT with you. Okay. Now we have to check engine performance with some parameters. We have to check engine performance means what actually we have to analyze. How much is the rated power? See, when customer will come to you and he will ask for engine, or you have to buy engine. So what he will ask, how much is the rated power? So this parameter he will ask. So we have to work on this parameter. How this parameter will be maximum for our particular design engine, that we have to learn, or that we have to analyze. Okay. So maximum rated power. What is that maximum rated power? When that particular vehicle, means we mount an engine on vehicle, and when that particular vehicle will run at its highest speed and load will be maximum. Suppose there is one bus, and how much is the capacity of that bus? Suppose if people are seated in this bus and vehicle speed will be maximum. Suppose its maximum speed is 120 km. But rated power, how much maximum power that engine can produce at that particular position or that particular condition, that is nothing but rated power. So this way we can calculate this maximum rated power. To calculate this maximum rated power, what parameters we analyze then? How much is the velocity of that vehicle and how much is the load on that vehicle? If we think about engine only, then what parameters we have to learn to calculate maximum rated power of that particular engine? We have to know how much is the speed of that engine and how much is load added, or how much is the force which releases the motion of the shaft. So these two parameters we have to learn to calculate maximum rated power. Now normal rated power is what? Highest power developed by an engine in continuous operation. When load is not full load but it is partial load, that is continuous operation. So at that time how much highest power we are getting? So at various load values, how much highest power we are getting? That is nothing but normal rated power. Now rated speed. Rated speed is maximum speed of that vehicle or maximum speed of that engine. The crankshaft rotational speed, if you are thinking about engine only, the crankshaft rotational speed at which rated power is developed, that is nothing but rated speed. So which we have discussed. The example of First we have discussed. So 120 km is the maximum speed of that vehicle, means that will be the rated speed of that vehicle. Or if you are thinking about engine only, this engine can run 1500 rpm maximum speed at 1500 rpm maximum speed. So that will be the rated speed, and we can get maximum power at that time, rated power at that time. Okay. Also we are familiar with basic terminology. In unit 1 only we have studied this. Let's revise this because we have to solve some examples on this engine performance. So we require all these parameters. Okay, bore diameter. What is bore diameter? It is cylinder diameter. Here you can see cylinder diameter. It is denoted by B here, but we have to use capital D for bore diameter. It is not piston diameter. It is cylinder diameter. TDC, top dead center. When this piston will move upward and it will achieve its maximum position, that is nothing but TDC position. Then BDC position. Now see, piston will move from this TDC position to bottom dead center. That is nothing but its bottommost position, that is BDC. Then if you see stroke is what? Piston will move from TDC to BDC. That is stroke. So that is linear movement. How much will be the maximum linear movement? That is nothing but is stroke, the distance through which the piston moves from TDC to BDC. Okay, or BDC to TDC. That is nothing but is stroke length. The stroke length will never change. This diameter, bore diameter will never change. TDC and BDC position will never change. So its swept volume will not change, and clearance volume also will not change, because they are function of bore diameter and stroke length only. Okay, so here some facts are given. Bore sizes of engine ranges from 0.5 down to 0.5 centimeter. So you have to remember this. An engine with D is equal to L. We are using D, capital D for bore. So D is equal to L. That type of engine is square engine. When L will be greater than D, that type of engine is under square engine. So that will means it is tallest engine. You can see means it is taller engine. It is taller engine comparatively, like this. And when stroke length is less than bore diameter, that is over square engine. So you have to remember this for online exam. They will ask this. Okay. Now, if you compare this under square, over square, and normal engine, that is square engine. Normally we use under square engine. L is always greater than D. Why we kept this L greater than D? If you see, L is greater than D. D is smaller. Here they are showing D is L is 2D. That is specific measurement. Okay. So why it is kept smaller? If you see, there will be clearance volume, or there will be combustion chamber volume here, and spark plug will be here. So distance between spark plug and end charge, that will be less here. And if you see, D is bigger or D is longer as compared to this. It is bigger value. So spark plug will be here. From this spark plug, end charge distance is longer as compared to this. So what happens? Knocking will be less here, knocking will be more here as compared to this. Why knocking will be more? And here there will be more and more knocking. Why? Because distance from spark plug to end charge is larger, so it will take more time to burn this charge, and when that charge will get burned from here, this end charge will get compressed and it will ignite and knocking will happen, detonation will happen. So we prefer this type of engine, that is under square engine. What is advantage of this? Stroke length is less. So stroke length is less, so smaller crank we use here, smaller crank, and smaller shaft we require. But what power we are getting, that will be less because there is knocking. Also see some concepts about terminology, that is clearance volume. Clearance volume is nothing but combustion chamber volume. The manufacturer will decide this volume, he will do some research work, and then he will decide how much should be the combustion chamber volume. Swept volume, what is swept volume? Pi by 4 D, that is bore diameter. D is a square, pi by 4 D square into L. L is what? Stroke length. So that is swept volume. If there are n cycles, then n times there will be suction of air means pi by 4 d square L into small l. Okay, you can see clearance and swept volume. See, this is TDC position. Above TDC, what volume is there? That is nothing but clearance volume. Below TDC to BDC, that is, your piston will move from TDC to BDC, that is L, and the cross section area of that cylinder, that is pi by 4 d square. So we know cylinder volume, that is pi by 4 d square, area into length, that is height. So pi by 4 d square L, that is nothing but swept volume. We also call it is displaced volume, because piston will move from TDC to BDC and that volume will increase. So we say it is displaced volume. So generally we kept these operating parameters. If this is aeroplane 2-stroke, if it is automobile 4-stroke, if it is large stationary 2-stroke, means our generators. So how much will be the bore diameter? It is around 2. And how much here is the bore diameter? 2.42. If you see, it is centimeter. 2 centimeter, 9.42 centimeter, 50 centimeter, like that. So these are the various parameters that we generally use. Okay, cylinder capacity. What is cylinder capacity? Engine sizes are compared on the basis of total cylinder swept volume, known as engine cylinder capacity. Thus, it is equal to the swept volume of each cylinder times the number of cylinders. So, what is cylinder capacity? That is CC. We always say 180 cc bike or 100 cc bike. What it means? It means it is swept volume, pi by 4 d square L. So, as cc will be higher, as compared to 100 cc, 180 cc will produce more power. So, if swept volume will be more, it will produce more power, because more charge will accommodate in that volume, because volume is higher. So, more charge will get accommodated in combustion chamber, and when it will burn, more and more power, more and more heat will produce, and more power we can produce. Compression ratio, this is very important parameter. From this parameter, 2 to 3 questions they can ask in online exam. It is the ratio of the maximum cylinder volume when the piston is at BDC. So when piston is at BDC, see, when piston is at BDC, there will be clearance volume plus swept volume. So clearance volume plus swept volume is nothing but total volume. And what they are saying, what's the definition? It is the ratio of what? Total volume divided by clearance volume, minimum cylinder volume. And we know when piston is at TDC, what is minimum volume above TDC? That is clearance volume. Simply we can say total volume divided by clearance volume is nothing but our compression ratio. Total volume is swept volume plus clearance volume divided by clearance volume. Simple, and we denote it by R. So we have to use R only. Okay. If we compare compression ratio for various cars, most of the cars has 8:1 to 12:1. This is petrol car. So for petrol it is 8:1 to 12:1. In your book, if you have seen, the range is they have given it is 6 to 12. So in exam also you have to tick on 6 to 12 compression ratio for petrol engine. For high performance cars, if car is high performance car, we always keep compression ratio 15:1. After compression, pressure will increase, and after heat addition again pressure will increase. If compression ratio will be high, compression pressure will be high. If compression pressure will be high, what power we are getting, that also will be high. Power is function of pressure only. We know that W is equal to P delta V. So work done or power is function of pressure only. How we can increase our pressure? By increasing compression ratio. For diesel, it is 20:1. Generally, we keep 20:1. What engine we are having in our lab, its compression ratio is 16:1. Generally, the range is around 40 to 20. In some books, 14 to 22 given. So we have to tick on 14 to 20 if it is diesel engine. Mean piston speed. This is very interesting concept. Mean piston speed. When we are saying mean piston speed, then we are talking about average linear speed of piston. Now, how to calculate this linear speed? By this formula, we calculate linear speed. Here you can use C also. This C notation also we can use for speed, or small v also we can use. But generally we use for specific volume, small volume. So you can use C here. So piston speed is equal to 2ln divided by 60. What is L? It is stroke length. What is N? It is RPM, engine RPM. So 2ln from 60. From where we have got this formula? From here we have got this formula. If N is the rotational speed, then 1 by N is the time for one rotation. If engine RPM is 3000 RPM, then for one rotation, how much time is required? 1 by 3000. That much time is required for one rotation. Half of this is how much? 1 by 2n, means for one stroke. One rotation means 2 strokes. For half rotation, there will be one stroke. But for one stroke, there should be one rotation. That is time for one stroke. And what is speed? It is distance upon time. How much distance you have to travel? Piston have to travel TDC to BDC. When you travel TDC to BDC, that is one stroke. For this one stroke, how much time is required? This much time is required. So 1 by 2n, that much time is required. So 2ln divided by 1. That is what? Piston speed. But 2ln divided by 1 or 2ln, if the speed is per minute, if you have to calculate meter per second, then you have to divide it by 60 again. So what will be the formula? 2ln divided by 60. So you have to remember this. On this formula you have to solve 1 mark online question. Determines the instantaneous flow rate of air fuel into the cylinder during intake, exhaust flow out of the cylinder. So what is role of this piston speed? As speed will be higher, inertia will be higher. As speed will be higher, more and more fuel will get pulled inside cylinder, or more air will get pulled inside cylinder in case of IC engine, in case of CI engine. Higher piston speed would require larger valves. If we have kept speed constant, the suction pressure inside the combustion chamber at the time of suction, that will be large. So we have to keep inlet wall bigger, so more and more air or air fuel charge will introduce in combustion chamber. So this is out of your syllabus, but you should know terminology. So I am going to explain this. See, now we are familiar with terminology. Now see, this is what piston displacement. If in online exam they ask what is piston displacement and some values are given, how to calculate this piston displacement? See, piston displacement is y is equal to L plus A minus S. Now what is L here? What is y? That is piston displacement. Piston was at TDC, it will move from TDC to BDC. Now it is here somewhere. It is not at BDC, but it will tends or it will moving towards TDC. Now the position is this. This is one specific position or instantaneous position. How much it has traveled, y distance it has traveled, that y we have to calculate. So y is equal to L plus A minus S. What is L? That is crank rod length, it will not change. A, that is crank rod length, it will not change. But if you see, this S is imaginary. It will change. As this will move, it will change. When this point is here, S will be L plus A. When this point will be here, S will be L minus A. So this way it will change. If you have to calculate S, there is again one formula. That is what? S is equal to A cos theta. A cos theta is what? Component of this A on this line. This is cos theta. So this component, this much will be the A cos theta. L square minus A square sin square theta. They have used Pythagoras theorem here. And they have calculated L cos theta 1. So if this is theta 1, they have calculated L cos theta 1. So that will be L square minus A square sin square theta in root. So if we added that both components, this plus this, that will be S, and that will be subtracted from L plus A, crank rate, crank length and connecting rod length. त्याच्यामधून हे S आपल्याला मायनस करायचं आहे. When the piston is at TDC, when the piston is at TC, S is equal to L plus A. The cylinder volume equals the clearance volume VC. The cylinder volume at any crank angle is thus the cylinder volume. You know what is cylinder volume? That is VC plus ACY. So when piston is at this position, how much is the volume? That is clearance volume, and this much is the volume. So cross section area into height. So cross section area is constant, it will not change because pore diameter will not change. AC is what? Pi by 4 d square. Pi by 4 d square. They are using P, we are using D. VC plus pi by 4 d square into height. How much is the height that we have calculated? That is nothing but L plus A minus S. Y is nothing but this height. L plus A minus S. The compression ratio is VC plus VD, that is swept volume divided by VC. Clearance volume. So more analysis you can do here. If you do this, that will be helpful to you to learn that concept or to know that concept very well. Okay. Piston velocity versus crank angle. This is also out of syllabus, but I am going to take this slide. Why? Because the concept will get clear with this slide. Piston velocity versus crank angle. See, this figure was there shown crank angle versus this piston speed, piston velocity. So you can see now piston is at TDC here and piston is at PDC. When piston is at TDC, the velocity is 0. The piston is at PDC, velocity is again 0. So piston will travel from TDC to PDC. At TDC it is 0, BDC it is 0. When it is at the middle, 90 degree, means piston will be here. Piston at TDC 0, at PDC 0, and in between, at the middle, the speed will be higher. So what this characteristic shows, at the middle piston speed will be higher. And what is this R? That is L by A ratio. You know L is what? Connecting rod length, and A is what? Crank length. So that is R. And if we see, and if connecting rod length increases, means connecting rod length increasing means what? Stroke length is increasing. Now see torque. Torque is very important factor. When we are seeing that torque, resisting torque that we have learned in our practical sessions, what is resisting torque? When we add a load, when we add load on engine, it produces more power. We are adding load means what? We are resisting motion of the shaft. So when we are adding load on engine, so we are using brake rope dynamometer to add load. So when we add load on brake rope dynamometer, the radius of this brake rope into load added, that is nothing but resisting torque. So to overcome this resisting torque, engine have to produce power. We can learn vehicle analogy also. What happens in vehicle? Suppose there are 30 people seated in that vehicle. Suppose there is one bus and 30 people are seated. So indirectly this load will go to tires, that vehicle tires. Vehicle tire motion will get resist, speed will lower down, and what driver will do? It will supply more fuel. He will accelerate and he will supply more fuel. As more fuel is supplied, what happens? Speed of the vehicle will increase. More fuel is supplied, more power will produce by engine, and more driving torque to overcome that resisting torque will produce, and engine speed will again increase. Of engine, it is equal to the product of the force acting along the connecting rod length and the perpendicular distance between the force and the center of rotation of the crankshaft. We use brake rope dynamometer. So that drum center to drum perimeter, that distance we take as a perpendicular distance, and how much is the force, how much load we are adding, that downward movement of that force, that is nothing but force that we take for calculation. So T is equal to F into R. This is resisting force and this is drum radius. what they are given, the force value they have given. How we calculate that force value? Now, if force is applied this side, so perpendicular distance we take. So, if your force is applied here, means at various triangle, force will get applied at various position. So, perpendicular distance we have to take. Now, this is force, so perpendicular distance is this. More will be the perpendicular distance, less will be the force. Now, very important factor or very important parameter we use to analyze engine performance, that is brake power. We are seeing horsepower. What is horsepower? 1 HP is equal to 746, that is unit. But this is concept. What is brake power? The engine power is nothing but brake power. Which engine power? The power available at output shaft of that engine is nothing but brake power. See, the term brake power is used to specify that the power is measured at the output shaft. This is the usable power delivered by the engine. So, customer is interested in brake power. How much that engine can produce power? That is brake power. How much that engine can deliver? That is brake power. That engine will produce indicated power, but at output shaft, what power we are getting? That is brake power. So customer is interested in brake power. When we say rated power, that is nothing but brake power. And what is the power produced in engine due to combustion? That is nothing but indicated power. When heat energy will convert into power, that power is nothing but indicated power. So this power we are getting in combustion chamber. That piston will get pushed down. Due to this power, piston will get pushed down, and the reciprocatory motion will convert into rotary motion of crankshaft. So at crankshaft is nothing but output shaft. At the outlet of that crankshaft, what power we are getting? That is brake power. Due to combustion, what power we are getting? That is indicated power. So indicated power is always greater than brake power. Why? Because when we are getting indicated power and we have to deliver that power to the shaft, there is some friction in between. We say it is friction power. So indicated power minus friction power is nothing but brake power. So these curves are given. See, engine speed versus power. These curves are given. So these curves we have to analyze for various displacement value. They have given. Suppose your engine size is, cc of engine is 2.5 liter, means it is car engine 2.5 liter, and now another engine that is 3.2 liter. So two engines we are going to compare. So if engine speed increases, see, as engine speed increases, we are getting more power. As engine speed increases, what power we can produce by engine, that also will increase, and it will reach at its maximum position, maximum power we can get. How much maximum power we are getting? This much power we are getting, around 200 kilowatt power we are getting at around 6500 rpm. So this much maximum power we are getting, and that power is again increasing. As speed increases, further it will decrease. So we have to keep speed 6500 to get maximum power, and as cc of engine decreases, means less fuel we are going to introduce at the time of suction in combustion chamber. So less fuel is introduced, less power will produce as compared to this. So you can see the curve is below this curve, and nature is same as this. There is slight different, but nature is same. Now see here, torque. Torque is what? F into R. So as speed increases, torque increases, and then it will decrease. So that is one of the characteristics. Indicated power increases with engine speed, while brake power increases to a maximum and then decreases. Our engine power depends on mean effective pressure. So this is very important concept. Our engine power is the function of this mean effective pressure. If you see here, this phrase, they have mentioned mean. Mean means average effective pressure. So what is effective? not just pressure, they are saying effective pressure. So this effective pressure is the reason we are producing power in engine. The pressure inside the cylinder of an engine varies considerably during the cycle. Peak pressure occurs just after TDC. So piston will move from BDC to TDC for compression. At the end of compression there will be spark, and the piston will move from TDC to PDC. We say it is expansion stroke, and most of the fuel will burn after 50-degree TDC. So what they are saying, the pressure inside the cylinder of an engine varies considerably during the cycle. Peak pressure means maximum, highest pressure. Peak pressure occurs just after TDC. At what crank angle it will observe? Around 20-degree it will observe, because all fuel will get burned 50-degree after TDC. So around 20 to 25-degree we are getting peak pressure, and it drops as the piston moves from towards BDC. Piston is moving from TDC to BDC. Volume is increasing. As volume is increasing, pressure is decreasing. Initially pressure is increasing because there is combustion is happening, so pressure is increasing, volume is also increasing. But as piston will move towards BDC, volume will increase more and pressure will lower down. When quoting cylinder pressure, it is therefore more helpful to refer the average or mean effective pressure throughout the whole power stroke. Why we use mean effective pressure? Why we use mean pressure, average pressure? Because when piston will travel from TDC to BDC, we are not getting same value of pressure. We are getting different values of pressure. After some crank angle, after some degree of crank angle, we are getting highest pressure. Then pressure is decreasing. So we are getting one curve. If we plot that pressure versus crank angle curve, it will be like this. It will be like this. It will increase first and then it will decrease. Like that we are getting that curve. So average value we have to take. That average value is nothing but mean effective pressure. How to calculate this brake mean effective pressure? The formula is given here. We are not using this formula. I will tell you the formula. Brake mean effective pressure. Brake mean effective pressure is equal to brake power divided by L A small n into small k. Now what is brake power? You know, power available at output shaft, that is brake power. In denominator, what we use? What we write? L is stroke length, A is pi by 4, D square, D is bore diameter, into small n, that is capital N by 2 for 4-stroke engine. That small n is number of cycles we can say, and small k we use for number of cylinders. If it is single cylinder, k is equal to 1. If it is 4 cylinder, k will be 4 in that case. So this way we can calculate this BMEP. Okay. The maximum BMEP is obtained at WOT. What is WOT? That is wide open throat. What is wide open throat? We have studied carburetor. In carburetor there is throttle valve. We know as throttle valve is wide open. Wide open means it is 100% open. When it is 100% open, air will come. That will be in large quantity, or its highest quantity will come inside. So throttle valve is open fully, means more air will introduce at throat of that carburetor. More pressure will drop, more fuel will get drawn, and its velocity also will be higher. So maximum BM is obtained at WOT. More fuel will be drawn at throat, so more power we can produce. Means more fuel is going to introduce in combustion chamber. More power will produce. So to get maximum BMP, we always keep WOT, wide open throttle became. Closing the throttle decreases BMP. As we are going to close that throttle, means as we are going to decelerate, then less fuel we are going to introduce, less power will get produced in engine, because that time pressure will be less, average pressure will be less combustion will happen. For a given displacement, a higher maximum BMEP means more torque. For a given torque, a higher maximum BMEP means smaller engine. So this thing you have to remember. They can ask this in online exam. Higher maximum BMEP means higher stresses The temperature in the engine, hence shorter engine life or bulkier engine. As BMP will be maximum, higher thermal stresses will induce, because pressure will be high. As pressure will be high, temperature also will be high. We know, as there will be compression, temperature will increase, heat will release and temperature will increase. As temperature will increase, higher thermal stresses will induce, higher stresses on material will induce, and there will be deformation or distortion of that engine and its life will decrease. For the same BMEP, 2-stroke have almost twice the power of 4-stroke. Why twice the power of 4-stroke? Because in 4-stroke engine there is suction, compression, expansion and exhaust. Two rotations will be there for one cycle, and here only one rotation, one cycle. So less friction value is there, and we know indicated power minus friction power is equal to brake power. As friction power will be less, brake power will be more. The maximum BMP of good engine design is well established. For SI engine, if you see the value, that is around 850 to 1050 kilopascal, means around 8.5 bar to 10.5 bar. CI engine 7 bar to 9 bar. For various vehicles, various characteristics are given. This is very important chart, because when we buy one motorcycle or one car, we go through this various specification. So we should know what are these various specification. From where we have got this specification? By doing engine analysis, engine performance analysis, we get this various parameters. Now see, Mazda Protege LX. So this is one vehicle, name of the vehicle, and the engine type is what? L4. L4 is the engine type. Displacement is what? 1.839. So this much is the displacement. Maximum power, (122) is the maximum power, 122 HP. You can see his displacement is how much? 1.839. This must be meter. 1.389. So this much bigger engine is there. That much bigger engine. 122 HP. That much power it can produce. You know, our normal mixer, it is 0.5 HP or 1 HP at the most. But here, how much power it can produce? 122. At what speed? When speed will be 6000 RPM, it can produce 122. Maximum torque. How much maximum torque it can produce? 117. And as at 4000 it will produce 117. And we know as speed increases, torque value decreases. BMP value, this much maximum we can get. BMP at rated brake power, this much we are getting 9.9. This is brake torque. Now see, Mazda Millennia S L4 turbo. So you can compare this. This is normal engine and this is turbocharged engine. So if it is turbocharged, its displacement is also higher, or it is bigger. Longer, it is 2.255, and we are getting more power as compared to this. This engine can give 210. Its sweep volume is also bigger as compared to this. So it will give 210 at 5300. When engine is bigger, its RPM will be lower, because inertia can distort that engine. Maximum torque 210 pound-foot. That will be the maximum torque at 3500. And BMP, the large value we can get 15.9. If you compare this, see there is a difference of 5 bar. BMP at rated brake power 15.7, as compared to this, it is larger value. So this way you can compare. I will share this slide with you. So let's see this summary. Both torque and power are functions of engine speed. At low speed, torque increases as engine speed increases. As engine speed increases further, torque reaches a maximum and then decreases. So maximum engine speed is 6000. But when, and we are getting maximum torque at 117. but when engine speed is 4000, then only we can get 117. After 4000, torque value will decrease. Engine speed can increase up to 6000, but we are not getting 117 or more than 117 after 4000. As engine speed increases, torque reaches a maximum and then decreases. Torque decreases because the engine is unable to ingest a full charge of air at higher speeds. As speed increases, we know piston velocity also increases. As piston velocity will increase, it can pull more air. But what they are saying, the engine means piston of that engine is unable to ingest a full charge. It is unable to pull more air in combustion chamber, so it is not lean burn and pressure also will not increase. So what torque we are getting, that is not greater than maximum torque, it will decrease after some time or after increasing speed. Indicated power increases with speed while brake power increases to a maximum, then decreases at higher speed. Okay, so indicated power also will increase and then decrease. Means it will, if we are talking about brake power, what happens with brake power? It will increase and decrease. Indicated power, it will increase and brake power will decrease from here, and indicated power will decrease from here. So this will happen with indicated power. For automobile engines, maximum brake power occurs at about 6000 to 7000 rpm, about 1.5 times the speed of maximum torque. So this thing also you have to remember. Greater power can be generated by increasing displacement. Displacement increases means what? Cc of engine increases. Cc of engine increases, more fuel will introduce in combustion chamber, more power we can produce. MEP increases, power increases. BP is equal to MEP into LANK. So power is function of MEP. MEP increases, power increases. Speed increases, power increases. Brake power is equal to 2 pi NT. So power is function of speed also. Increase displacement increases engine. What is this displacement? Brake power is equal to P into LANK. So we know the formula. Work done is equal to P into delta V. So if we compare these both formulas, brake power is equal to mean effective pressure, that is P, into displacement, that is LANK. So L is stroke length, A is bore diameter, into small n, that is number of cycles, into K, that is number of cylinders. Increase displacement, LANK increases, our brake power increases. Okay, what they are saying, increased displacement increases engine mass and occupies more space. Displacement increases means what? LANK decreases, L increases, A increases. Means L increases, bore diameter increases. Means engine will be bigger in size. So if engine will be bigger in size, engine mass increases and occupies more space, and both of these are undesirable. Okay, we don't have to increase bore diameter or stroke length, we have to increase power. As this displacement increases, power increases, but we don't have to increase displacement. So what are the parameters on which we have to work? We have to work on MEP, we have to work on speed. If we increase displacement, that will be bigger size engine. Its production cost will increase, our overall vehicle cost will be higher in that case. For this reason, most modern engines are smaller but run at high speeds and are often turbocharged or supercharged to increase MEP. So what is our focus? Our focus is to increase MEP and to increase speed. So these parameters, or these two parameters we have to research. So thank you.